Okay, so today we have our last student presentation on the topic of pairing and access control. The paper's name is Kurato's multi-user, multi-device aware access control system for the smart home. So without further ado, let's start the presentation.
All right, could everyone see my screen?
Yes.
Okay. So today we're presenting Kratos, a multi-user, multi-device aware access control system for a smart home. So a brief overview of what we're going to go over. So we're going to go over the motivation and definitions of why Kratos was created, the problem and threat model that was associated with it, the design and implementation, the performance evaluation of Kratos, and the benefits and future work. And then we'll go over the related works afterwards. So in a home, there's a growing number of smart home devices such as like smart speakers, printers, light bulbs, or like even thermostats. And originally, these smart devices only had one user or only expected to have one user. But then now they can be expected to expose to like multiple users who have control over like each device. So multiple users can lead to conflicting demands, such as the thermostat. One person will want to set the temperature to like around 70, but the other one wants to set it to 80. So you have to figure out which command to fulfill, or do you just have a conflict and not decide what to do? So current control mechanisms, there are some implemented, but they have security issues where if you were to just install the app, you would gain instant control over that device rather than having to go through a security system to make sure that you're an authenticated user. So this is where we introduce Kratos. It's a multi-user, multi-device aware access control system. So it does this by implementing a formal policy language, which decides who has access to what and has much more rules than like just access, but also like, oh yeah, it's more descriptive actually. So it implements a policy negotiation algorithm. So this leverages the user roles and priorities. So if there were to be a conflict in a demand, it would start this negotiation algorithm and see what the best fit to fulfill both demands. So after it figures out what policy it should enforce, it's going to implement it and enforce it. So the motivation of, oh, yep.
So far, yeah, I think Assumption made a similar comment before. What is their adversary model here? This sounds like a multi-user kind of
Oh, so
reconciliation system.
we'll talk about the threat model later, but I could say right now, some the attack models are new users where they're trying to gain malicious access to your smart devices, such as your smart locks, existing users who are careless and they might accidentally give permissions to like malicious users or just accidentally do something.
So you're considering the cases where among the multiple user you have one or many of them are malicious, or the cases that you have one or multiple of them are kind of let's say careless.
Yeah.
Okay.
Okay. So the motivation of creating Kratos, we want we want to allow the users to be able to share the same devices who may have conflicting needs. So as I said before, there are existing solutions to solve this problem, but they're device specific, as in, say you have a smart fridge. That smart fridge only has a specific app to work with it, and it doesn't work with all like your other smart devices. And along with this, it introduces only minimal security, such as if you have the app installed, you could gain full access to that device. So this proposed system needs to be able to understand user dynamics and assign appropriate policies. So it has to be able to fulfill as many users' wants as possible, depending on what priorities they are, and then assign it and enforce it. It also has to be able to be fine-grained, so it allows for user-specific policies to be implemented. And so for example, for families, you want to be able to like share access to your locks or your light bulbs or like your smart coffee maker. For roommates, you want to be able to have only access to your specific lock to your door, and your roommate doesn't want you to have access to their door either. So you need to have fine control over that. Or an Airbnb where the owner wants to give a guest access to the lock, but then they only want to give it to you for like a specific amount of time. After that, it would expire and you don't have access to the home anymore.
So you are considering fine-grained access based on the user's role or the attribute of the device. And you are considering the cases you want to have an easy revocation process once the user's access or delegated access expired. You want it to no longer be able to control the device.
Yeah, you want to revoke their access.
Okay. And what would be their solution?
So, okay. Their solution would be to implement like a formal policy language so you're able to implement these demands and you could do it specifically per user.
Okay. So they define a formal access policy language.
Yeah.
But I think there are something like a conjunctive normal form as disjunctive normal form that has already been used for access policy, right? What's the advantage of their method?
I think they said that it's because it's able to work with multiple devices, or like it could work with all your smart devices, and you have a lot of like granularity to what you can control and what you can't control. I think it's also because of their priorities and their negotiation algorithm that makes this unique.
But okay, I can kind of see. But just I have been I worked with this a while ago when I was a PhD student. Um, on the topic of cryptographic enforced access control, fine-grained access control. So the algorithm or the crypto device that we use is called a attribute-based encryption, ABE, or it's called uh,
Attribute-based access control system?
attribute-based encryption. So basically, the idea for that encryption is you have a master key and you can create a different key for different user containing different subset of attributes. And only if the attribute match a certain kind of a policy tree, you will be able to decrypt. So while I was working on that topic, I learned that there are two types of access control system. One is called policy-based. The other type is called let me think. CAB, text policy, and policy, text attributes. Right. So basically, the idea of a formal access control language is you define a policy.
Yeah.
What do I mean by policy? The policy looks like a tree. So at the root node is whether you grant access or not. Okay? And you define the policy as a tree structure. So at the leaf nodes, you will have a bunch of attributes. And each of the internal nodes on the tree is a logic operation, such as a AND, a or something like a 1 out of k. Okay, so you see that you can define this access policy based on the tree structure. You see that only if this person has attribute A and attribute B and one of the A attribute among C, D, E, F, you will be able to go all the way to the top of the tree, which you will be able to grant access control. Does that make sense?
Yeah.
So it's a tree structure. So that is the policy. On the other hand, you will have a set of attributes that you delegate to. You define a user or device. Let's say this user is a doctor and is also simultaneously a lab technician and simultaneously some other roles. Let's say, so those are the role or attribute of this user. Only if this user's attribute match the policy, you will be able to grant the access control. So that's the basic idea. When you define an access control system, you will have an access policy, you have a bunch of role or attributes for this user, and then you try to match them together. You can switch it around. You can define this person using a policy. This person has a policy, and you define the access document with a bunch of roles. So there are different ways to do that. But that's basically the idea of an access control language. So are they doing something similar to that?
I think it's kind of similar, but instead of assigning rows, you just assign them everyone a unique ID. So
right. So if you are assigning an ID to each individual person, that means for n user you have n roles, right? Each one will have a distinct role.
Yeah.
That's a more simplified version than the policy role-based access control, because now you have an ID-based access control where you have individual individual user with different roles. But that's basically just a nomenclature for you to define a access control language. But that's very normal. So you are saying they're basically they're doing this kind of ID-based access control policy, right?
Yeah, and they're also able to implement specific rules for each device rather than for each role.
I see. Okay. All right. Let's move forward. Let's see what they actually detail about it.
Okay, so before we get into it, we have to define some definitions. So, alright. So for policies are the group of requests that are made by the users. So a demand policy would be a group of requests that the user makes that they want like control over a device. Restriction policies would be the set of rules that governs like which devices that each user has access to and the time frame that they could use it and control it. Location-based policy, it's a set of automation rules where it's enforced if someone is within the area or if they're connected to the network, and it also determines who has remote access to that device. For priority, that's the importance level for each user. So we could create a hierarchy of users from priorities. For conflict, so this is the dispute process that happens when you have demand policies that conflict with each other. So such like, as I said before, the thermostat, one user wants to set it to one temperature, but the other user wants to set it to another temperature. So a hard conflict is where the demands are, they have no overlapping features to them. So such as if you were to set the thermostat, one person wants to set it to 70 to 80, or the other person wants to set it to 50 to 60. They don't have an overlapping temperature, so that's a hard conflict. For a soft conflict, it's where if they have an overlapping condition or an overlapping feature to them. So such as the thermostat again, if you were to 60 to 70 for one person and maybe 65 to 75 for the other person, they have an overlapping temperature. So that's a soft conflict since they share a common feature.
Okay.
For restriction conflict, that's where a user tries to have access to a device, but they're restricted from having access to it. So a device has a restriction to not unlock itself at like after 12 o'clock a.m. to 6 a.m. But a user wants to unlock that door at 3 a.m. So that's a restriction conflict.
So the policy you described, the demand policy, restriction policy, location-based policy, and those policy will be staying with the device.
The restriction policies stay with the device. The demand policy goes through Kratos, and basically it asks Kratos, am I able to have access to this? And then Kratos looks at the restriction policies in place and the location-based policies and determines if this demand policy has access to the device or not.
So you have a gateway system which enforce access control using the demand policy and restriction policy.
Yeah, along with
And then
location
when you
policy.
actually reach that device, you still have a location policy on that device to determine whether you'll be able to use it or not.
Yeah.
And where does this Cradle protocol gonna stay physically? Is it implemented on every devices?
All right. So I think we'll get onto that a bit more, but it's basically if the device has an app, Kratos is gonna be malicious and it's gonna tag on a conditional statement to the end of the source code of that app. So it's able to have control over it.
So it's a hacked into that software
Yeah.
or the firmware of that device.
Yeah, kind of like that.
Okay. So in another words, it stay with the device.
Yeah.
Or it stay with the app that communicate with it.
Yeah, either one.
No, I think it's distinct because that app need to. So how you're gonna control a smart home is through something like your handheld device, right?
Yeah.
And
Oh,
when you right, I think it goes into the app in your phone.
so yeah, yeah. Okay, so what's it? So if a device has this app specific,
Uh-huh.
that's when they say we're gonna tag on this additional conditional statement to the source code of that app. So whenever you use that app, it's gonna go through Kratos to make sure you have access to it.
I tag on this conditional statement is basically saying that I'm going to wrap the entire source code of that app logic into a if-else statement, right?
Yeah.
So you're first going to check the access policy based on the information provided by your phone, like your current position,
Yeah.
right, which can be sensed through the phone, or something like well your roles, which will determine what is your restriction, right? And then if everything passes, it will actually go into that app and run the logic for you to access. Okay. All right. Interesting. If they can actually do that, that will be pretty cool.
Yeah, it's a lot of work though, sounds like.
Okay. All right. Let's move on.
Okay, and then lastly, there's device condition. So that's basically what restriction policies, what location-based policies are enforced on that device at that certain time.
Okay.
So to define the problem, we're gonna define 3 example problems to get an idea of it. So Alice and Bob, who are owners, they want to set the thermostat, but they want to set it at like different temperatures. So that would be a soft conflict. Alice would want to restrict access to the door after 12 a.m., but Gary wants access to it at 3 a.m., so that's a hard conflict. And the third one would be Alice wants Kyle, their child, to have access to the lights only if he's in the home. So they don't want him to have like access to the light if he's like outside because he's just gonna play around with it, I guess. And they want to prevent all other access for Kyle to any other device, such as their smart coffee maker. So that'd be a restriction conflict and a location access, where the restriction conflict is Kyle trying to access their smart coffee maker, but Alice restricted it. And the location access where he has to be at home in order to have access to the smart bulb. So the threat model, so for new users, when they're added, sometimes, or like not sometimes, they could get automatically full access to the system. So that could lead to undesirable device access. So if someone were to get added to the system, you don't want them to have access to your smart lock or like anything confidential. For existing users, you could assume that they might be malicious, such as your child that wants to have access to your smart coffee maker. So they could try and override system settings by installing new apps, like installing that new coffee app that could get you access to it. And they could try and delete device owners and abuse privileges from that. And then you have careless owners who could be very careless at what they control. So they could grant unknown people, so like they could grant new users access to their devices, or they could forget to remove a temporary guest, and that guest could stay within the system and they could collect confidential information. So the Kratos design is going to focus on a user-friendly interface, diverse user roles and complex relations, a conflict resolution, so that's the policy negotiation algorithm. And then policy expiration, so that's the time-based one, location-based access, expressive control, and a unified policy enforcement. So everything's enforced under one app.
Which is the Credo app.
Yeah. So within this Kratos app, it has a user interaction module. So this one's going to collect the priority assignment data and device policies from the users. So users could interact with this module and tell it what policies they want, or yeah, what policies they want. So through here, you could add new users and assign their priorities, and it's going to follow this formal format. So AID is the ID of the person adding the person. NID is the ID of that new person being added to the system. P is the priority level, so 0 is going to be the highest priority, such as administrators or owners would have. And anything higher is like your next level of priority, and next level, and so on. D is the permission to add and remove devices to the system. So if it's like, are you able to add devices or remove devices, and for which device too? T is the time that this user is valid for. So if this T is set, that means you're only going to be valid until this time has elapsed. So that's good for like the Airbnb situation we stated before.
So for each user, you basically have this kind of tuple or list. that define the user's attributes.
Yeah. And then so when defining a new user or adding a new user, their priority could either have the same priority or lower priority as the user that's adding them. They could also give permission to add and remove devices to the new user if they also have the same permissions as they can, or if they have the same permissions to add and remove devices. So what's good about Createless is that if this time is set, and after this time has elapsed, it's going to automatically remove that user. So you don't have to worry about manually removing them after the time is up.
So the issue is the reinstantiation if the user want to have extended this policy.
Mhm.
I mean, you have an automatic revocation process, right? But what happens if the user need to? So
Extend.
basically, if the user want to extend, you will have
You would have to ask the formal,
for
you have to go
another
through the whole
permission,
format.
right? Okay, so it's basically like the hotel system.
So
Okay,
each user could create their own policies through their device, per device, or per user. So like you could create a restriction for a device or a restriction for a user. And if you have conflicting policies, the priorities will determine which will override which. So higher priorities will override lower priorities. So the policy structure, it's going to follow actions, users, device, conditions. So actions is where it's like what action is this policy going to follow? So there's going to be restriction, location, demand. I think those are the three main ones. So you could see, for example, in U1, Alice, she wants to restrict access to the thermostat. Oh, no, not restrict. Restrict the thermostat to be within 60 to 70 degrees.
that's the user's hold on. The restriction, are you saying that
I
Alice
feel
can
like
only change the temperature between 60 to 70?
I feel like it should be demand. I guess it's the restriction to the temperature to be between 60 or 70. Yeah,
So that's Alice's demand.
that should be a demand, I think, too. Yeah, I feel like she's restricting the temperature to be within 60 to 70, but it would make more sense to demand the thermostat to be 60 to 70.
But it also has a restriction, so U3 cannot do anything to the coffee maker.
Yeah, so restricts user 3 from using the coffee maker.
And what is
And
the demand U4 stands for?
so U4 is Gary. So do I have a picture?
It's a guest.
Yeah, Gary's the guest. He wants access to that smart bulb over there, so
Uh-huh.
that's the bulb 4.
Which is not allowed.
Yeah, so, oh, he has access to it, because, well, it's like, since this is under user 1, or Alice sees the demand from Gary that he wants access to the smart bulb, so Alice could determine if he has access or not from that demand.
Oh, I sort of see. So the restriction, the location demand is basically the policy that you said earlier. So the whole thing is basically a meta or a group, a set of policies that user one can set. Let me see if I am understanding this correctly. User one can set the restriction for anybody that the thermos one's temperature cannot be set between 60 to 70. That's a weird restriction, but let's say that that's how this language example works. Then it set a specific restriction for user 3, saying that the coffee maker is off limits.
Yeah.
It says another location policy for user 3 says if you want to access one of the vault,
You have to be at home.
you have to be at home. And it basically generate or delegate what is demand policy? What's the idea of a demand?
So it's basically the demand is like a demand coming from user 4 asking for permission to have access to the bulb 4.
So that line says the demand from user 4 to access of bulb 4 is not uh, granted. Is that right?
I'm pretty sure, but that way, is that correct? I'm pretty sure that's
I think
correct.
the demand for bulb 4 means the user 4 have access to the bulb 4.
Oh, okay. Granted by user 1.
So it's granted. It's a granted demand.
Okay, so it's granted demand. Okay, my bad. I
Okay.
misunderstood this.
All right. So a restriction of user 4 to log at time. So user 4 cannot access the log between 6 a.m. to 9 p.m.
Yeah.
Right? Okay. And then it says user 2 want to set the restriction for the thermostat temperature to not between 75 to 80. Okay, and then it granted a demand from user 3 to access bulb 3 between time 7 p.m. to 7 a.m. And then it granted another demand from user 4 about the access to log 1 and log 4. So clearly there are some conflicts between those two policies issued by different users. So
Yeah.
the next step is basically reconciliate those policies, right?
Yeah, and go through a negotiation algorithm if possible.
All right, let's take a look at that part.
So, okay, so negotiation algorithm will be after this, but the backend module is where the user's credentials and device policies are stored. So it would take all of the user policies and it's going to create a list for like the priorities and the policies per user. If a user assigns an incorrect priority, so like if they assign a new user to be a higher priority than themselves, the backend module will notify that user and ask for a correction in priority.
Hold on,
So,
can you go back?
oh yeah.
What is the meaning of your last bulletin point? Incorrect priority.
So it's like backend where we are able to add new users. It follows the formal format where the new user defines the priority of that new user. So if that existing user defines the new user as a higher priority as themselves, that's like a breach in security. And so it asks the existing user to correct the new user's priority before moving on.
Okay. So basically, it's saying that the priority for a user is only a particular user can only create a user with lower priority as its own.
Yeah, the same or lower as its own.
Okay, so that's a relatively straightforward priority setting.
Yeah.
Okay, makes sense. It's basically a Unix priority system, right?
Yeah, pretty much.
Okay. All
All
right.
right. And then there's the policy manager module. So this one's going to collect the list that the backend module creates, and it's going to compare policies to see for any conflicts. So if any conflicts are found, we're going to start the negotiation algorithm. So first off, it's going to fulfill the higher priority users. But if it's a soft conflict in higher priority, it's going to offer a solution, but it's going to set the higher priority users' policies first. So it's like if you were to set the thermostat or like two users set the thermostat, but one's a higher priority than the other, but they have like a common range, like between 65 to 70. It's going to implement the higher priorities range first, but it's going to ask the higher priority. There's a common policy that's going to fulfill your policy and this other person's policy. So this is up to you if you want to implement this common policy or not. Okay, and then if there's the same priority, so if the two users have a conflicting and same priority, this is going to be a competition conflict. So this is where if it's a soft conflict, it's going to negotiate an average condition and create a common policy from that. If neither user wants to accept this policy, it's going to be unresolved. So it's going to notify a higher priority to resolve the dispute. Once
Well,
a common
this can easily go into a stalemate, in my
Yeah.
opinion, right? So
Again.
let's say that you have 3 person with you know, with the same level of priority, which can be true, right? So if you are living in a house and you have your adult children and your 2 parents, right? So all of them at some level they are equal to each other, and you have the same level of priority. And when you try to create a setting, and each pairwise user has a kind of intersection or some negotiable region within their policy, but none 3 of them does not have a common ground, then you basically have this kind of a philosopher dinner problem where you have a deadlock, right?
Yeah.
So this doesn't.
It doesn't go
it
well
can
with-
has problem. Okay.
Yeah.
All right.
Okay, but once it's able to determine what common policy it's going to create, it's going to send it to the backend and it'll be enforced afterwards.
So basically, it goes through a negotiation process with some kind of privilege among users to resolve a conflict, right?
Yeah.
So sometimes it will work and sometimes it won't work.
At which it
that's
should escalate the problem to a higher priority user.
Right. But what if there is no higher priority?
Yeah, that's
Right.
your stalemate.
Okay. All right. Let's move on. Okay, I see. So policy-wise, from a formal language perspective, it doesn't. This language doesn't address anything new. From a logic perspective, when you have concurrent process working on the same problem, you're always going to have this kind of issues regarding a deadlock.
Yeah.
So either you have a perturbation process, so you use some kind of random process to randomly pick one to remove the deadlock, or you have an arbitration process where you have someone with the final say. Otherwise, it's basically just continuously endless debate.
Yeah.
Okay. All right.
Okay.
All right. Let's move on.
And then the policy execution module. So this module will enforce the final policies. So as stated before, if you're modifying a device with a device-specific app, so such as like your smart fridge has a smart fridge app specifically for it, Kratos will append the conditional statements to the app's source code. So every time the device-specific app tries to make a change, it's going to ask Kratos if it's able to make that change.
Okay,
Alright,
so so the next, the Kratos implementation. So first of all, they collect data from 43 different users. They will ask them to do some setup, follow the data instruction, and they correct the data to see how many conflicts according to their policy setting. So based of those data they collect, they categorize 6 scenarios. First one is the multiple policies for the same device. The second one is the multiple policies for different devices. The third one is multiple apps for the same device, while the scenario 4 is a single app for multiple devices. They also have a temporary user scenario and location-based access scenario. Next, please. So they also have a malicious scenarios. There's 5. The first ones are over privilege control. So they will ask a user to add a restriction clause to the port. Add a restriction clause to the system and then ask the AE restrict user to change the policy. And the second one is the privilege clause. So they ask a new low priority user to install an app and trying to trigger the smart camera. And the third one's the privilege escalation. They will create a new user and ask the new user to change the code of a smart lock and then try to remove the smart lock from the network. So the fourth one's unauthorized access. They will ask a temporary user with lower priority to control a device outside their accept time range. And the last one's transitive priority. So in this case, they ask a lower priority user to add a user with higher priority. Next, please. And these are the user interface of their implementation. So the left-hand side is the user management. So they can add a new user by assign the user with a priority 0 to 4. And the 0 has the highest priority. Then the right-hand side is a policy management. The user can select the device and create a new policies. There are different policies. There's a time-based device policy and value-based device policy, or both type value-based device policy, and the device policies are following this format. The use is a device policy array P.
And what is C1 and C2?
C1, so C1 is the time conditions, while the C2 is the value conditions. So U is user ID, while D is device ID. And R is the restrict user. And then the last step is, and then the last step is the last one is the policy enforcement. So they will use 10 different official SmartThings app to control 17 different devices and install them on in the SH, the smart home system. They use this to observe the user-specific policies generate in the policy generation model. Yeah, and then they also had to modify those apps and let them connect to the backend server. Next one, please. So this is the performance of Kratos. So the first one.
So they have an app.
Yep.
And within the app, it contains your own policy or your own access control privilege token. And in the meantime, you can also create tokens for a user you want to, like a new user, you want to delegate a part of your access privilege.
Yes.
And you talk about enforcement. How is that policy going to be enforced again?
So I think they first will have a query to the backend server, and the backend server will run the table to see table lookup to see if the user has the access to a device based on the priority, location, or time range, and then it will send back the to notify the app that user can have access to a device.
So security-wise, this thing basically is you have a server that execute a policy matching or some kind of access control, and then it talk to both the user and the device to give you that handshake that allows you to communicate with the device, right?
I think so.
And by the implementation of Kurtros on the device is configured in a way it only talks to the backend server. It does not directly interact with the app on the user's phone. Right? So basically you put a server which acts as a application API which redirect the communication from the user to the device following certain access policy, right?
Yes. Yeah.
Okay. Well, that's very traditional, I would say. But still, there are issues. It depends on their threat model. What happens if that server has been tampered with, right? So if you have physical access to the server, which is not, well, not necessarily, because for most of the smart home device, some of them, for instance, require network access based on our previous discussion on the IoT devices, right? So Matthew and Brian, they all presented this paper for smart speaker, for instance. If you want to issue a command, the data actually sent to a remote server. So that means you have a server sitting on the cloud, which communicate with the device. So infrastructure-wise, you have this server client model where server in the cloud manage the access. So maybe it's doable. It's just there are certain amount of delay that we cannot ignore when we actually go through that server. And because the server is sitting in the cloud, meaning that you don't have physical access to the server, so it's less subject to malicious attack. Okay, all right, makes some sense with this architecture. Okay.
Okay, so
Let's
there
move
is
forward.
yes, there are several kinds of the conflict types. So the first one, the hard priority conflict, as we mentioned before. So if Alice and Bob both set the temperature in different range without any overlap. So because Alice has the higher priority, so the creators will set the thermostat range to the range that Alice set. So for the second one is the soft priority conflict. So they first you will set the temperature based on Alice's request, but you will also notify Alice with a common range with because their range has overlap. So if Alice agree with the common range, creator will set the temperature to the range
On that
60
common range.
to
Okay.
70. Yep. So
Right.
the third one, the hard competition conflict. So there's no overlap. If you notify the higher level user and all the admin to make a decision. So the first one is the soft competition conflict. So creators will automatically set the temperature in the range because they have overlap. The next one's restriction conflicts. So Alice has a higher priority, while so the creators will set the temperature on that range 60 to 70 and notify Bob. The next one is a temporary access. So because Gary's access has expired, so creators automatically detect the expiration of Gary's access and delete Gary from the user list. And so for the last one is the location-based access. So because Kyle is not, so if Kyle is not at home, so creators will disregard Kyle's access policy. So if Kyle is home, but Alice is not home, creators will set the temperature by Kyle's. But if both Kyle and Alice are home, so creators will set the temperature range 70 to 72. On next slide, please. So the first table 2 is the creators performance in different user case scenarios. So the average time is less, most of the time for about 30 to 40 policies, the average running times about 1 second, or less than 1 second, and the success rate 100%. For the table 3 is the performance of creators against the different threat. So again, for about the number of the 10 occurrence, the average detection times less than 1 second, and the success rate is 100%. Oh, they also list the average notification time to notify the admin or the user. Okay, next slide, please. Sorry for the doubt. Okay, and the next one is the impact of different parameters. So the first one's the number of policies. The second one's the numbers of conflicts. The third one's the numbers of users, while the last one's the number of devices. We can see this, the delays almost linear. It means the algorithm is efficient. Okay, next slide, please. So let's the next one's the benefit of future works. So for the creators, the benefits, they have a efficient conflict resolution. Is that they just we talked about before, it only takes less than 1 second to solve most of those conflicts. It also supports multi-user and multi-device. And it's also suitable for complex user demand because a user can use the access control language to send their demands. The last one's the interior security. Also, because they say that they have the certain rule to protect their smart home. So such of so for example, some of the devices should have the higher priority, such as the smart lock. Oh, next, and then for the future work, they think the future work is the user and usability study. So that's for we talked about before. The environment is just the experiment environment, not the real life environment. So the users just follow the instruction to enter some policies or demands. So they need to test their system in the real life environment. Next slide, please. So this is the relabel. Most of the prior works emphasize on limiting malicious activities via controlling app access. And some of them focus on single user scenario, but they don't provide a solution for multiple user access and the user conflicts. They also didn't provide a flexible conflict solutions. That's shown on the table 6. So Keratos, the only research had provide a threat model and a implementation to solve these problems. Next slide, please. So for the conclusion, they design and implement Kratos. So Kratos supports multi-user and multiple device environment. So it is a priority-based system. And it can resolve a conflict user demands automatically in most of the case, except those hard conflict require higher level user interaction. I think that means the admin had to manage those user priority very carefully. And they also evaluate Correctos in 6 user scenarios and 5 threat models. Okay, thank you. Done.
Thank you. Interesting paper. I think that's gonna start some kind of a discussion regarding multi-user IoT devices or smart home devices. Before I make my comments, so what was your impression about their solution, Thomas and Dawei?
I feel like it's a nice, or like, it's a solution to this multi-user, multi-device system, but
Okay, so intuitively, just give me what's your first impression? What do you feel is unnatural?
Unnatural.
Well, if you are the one of the user of the Kratos, will you feel comfortable or uncomfortable using this system, and which part are you gonna feel like is awkward?
I think it's when the hard conflict happens. Every time the users have to wait until the higher level user or the admin to make a decision.
I think for me, it's kind of like having to demand that you have access to something for like a lock or something. Because if you were to be like, if it's a physical device, you could just like unlock it, or if it's like a light bulb, you could just like turn it on and off. But you have to ask for access to it. That feels kind of weird to me.
Yeah, I agree. So I agree both of your impression on this kind of system. So I have been working on similar type of access control where you have multiple person or multiple users try to access a shared resources. This kind of any kind of a policy here will feel awkward or unnatural or some kind of annoying from the user's perspective, because I feel that by nature people just don't like rules, especially when this rule is it's forced on them. Okay, so any kind of policy without an explanation will feel kind of irritating. And any of the policy with a elaborated explanation will feel tedious to read through and reason through their logic. So my comments or my feel about this type of system design is maybe, just maybe, we need to change the premises of this kind of system, or let's say a smart home environment. So we have this multi-sensor, multi-environment, multi-device kind of at-home smart environment. Maybe our focus shouldn't be try to address this kind of conflict when multiple users try to access the same device. Maybe our focus should be focusing on just create a maximal level of separation between users, right? So it's like a software design. So if you have what your design eventually lead you to the point where multiple processes need to access the same resources, maybe it's not such a good design. Instead, if you can have, or you can implicitly create this kind of a scenario or a condition where multiple users just can share, I mean, access different resources at the same time instead of all rushing into the same resources at the same time. Maybe it's a better way. So, but my general feeling about this kind of system is, if you have a rule, if you have some kind of rule, you want to enforce it implicit instead of explicitly lay it out to users, because that's gonna make people feel kind of feel annoyed. So two comments similar to what you have regarding your feeling about this kind of design. First thing is, you want to minimize the conflict by creating scenario that try to avoid the multiple users sharing the same resources, right? Maybe you learn the user's behavior. Some user is more tolerated to the thermostat. Some user are less tolerated to the thermostat. Then you give some user sole access to the resources, and you just ignore the others, right? And the other thing is, you want to enforce your policy implicitly, except rather than explicitly. So instead of saying that right now, because you don't care, you based on your past history, you don't care about the thermostat's temperature, we don't give you access anymore. It just maybe give them a white lie saying that the thermostat is broken. Okay, so it's just to resolve the conflict in a more kind of arbitrary way, or a more it's a faster way to eliminate this kind of negotiation process, because I always feel that negotiation should be the last thing that happens when you are doing multiple users are doing something entirely. So for instance, if let's say one of the example is a version control system, right? That's something like your GitHub. You will only need to resolve a conflict when you and the other user try to access the same resources and you actually added the same line of a file. That is when you need to negotiate. For 90% or 95% of the time, you are doing your individual work at different part of the project, and you just don't have conflict. So maybe it's better to focus on those 95% of time, and maybe extend it to 96, 97, instead of trying to have a very hard rule to make those 3% of the time to have a better experience for all the users, because it's a I feel that you can see the ceiling there, because if you have a multiple user trying, each of them have a in different going in different direction, this conflict is unavoidable. So whatever you are trying to do, it will have some kind of inconvenience or feeling of discontent from the user. All right. So does that make sense?
Yeah.
Yeah.
Right. Okay. Let's do a few questions. So first one from Samson. The practicality by introducing increasing number of inputs to the user interface, would this be helpful for new, unexperienced users? Yeah, so Samson is asking similar questions, and actually he asked several of them. Let's try to understand the first one. Samson, can you elaborate on your first question?
Yeah, so I guess they have an app, right? or you can
Right.
control the I guess the policies or the priorities.
Yeah.
But I see that there are like a lot of parameters on the app. So would this be a friendly experience at a home environment, in your
I
opinion?
I'd say it's kind of overwhelming because if you have like young people or like children, it's gonna be they're gonna play around with it. They're not gonna really.
Yeah, not only young children, but also like, like old people who are not very versed in, technology, the
Yeah, I feel like
knowledge.
the current iteration of their app is not really friendly right now because it's like just a long scroll. Like you just keep scrolling to find what you want. So
Mhm.
yeah, the current implementation not that user friendly. I'm pretty sure.
Oh, just speaking of which, I feel that yeah, for intuitiveness, right? So this app or the control for this system is very difficult to. Well, it's not that easy for unexperienced user. That lead to my another comment that I can see how to improve the system. Let's say that we want to enforce a privilege in a chain of privilege or tier of privilege. And how do we enforce that implicitly? Let's say that for a taking the thermostats as another example, for tier one, maybe we allowed it to change the thermostat value, the absolute value, in a large range. Let's say from 60 degree Fahrenheit to all the way to maybe 80 degree Fahrenheit. And for tier two, maybe we ask them to give a dynamic range around the mean value set by the tier one user. Let's say that if the tier one user set it to 70, you can still change it from maybe 68 to 72, something like that. And the third one will basically piggyback or fine tune even further on the tier two setting. So that's basically will be a way to enforce this kind of explicit rule in this kind of rule in an implicit way, right? So on your app, this is the part that will make everybody feel a little bit more comfortable. All you have is a dial, right? It's maybe an analog dial without showing you the value, but it only allows you to tweak it within the dynamic range allowed by your tier. So in that case, there's no question, right? You don't have hard conflict, and so no everybody should be happy. All right. So instead of because everybody will feel annoying if you want to achieve a specific number and you cannot achieve that, right? But if you hide that number from the user, then everybody feel okay. I'm somewhere close to it. Maybe I'm fine. All right. So that's just one way to kind of to soften this requirement when we have a access control system. I feel that this is might be the way to go because you hide the conflict under the noise instead of make it more explicit and everybody try to argue with everybody. That's not the way. Okay, Samson, does that answer part of your question?
Yes, it does. Thank you.
So yeah. So I agree. You need an intuitive user interface, something that you can easily learn, so it doesn't have a very dramatic learning curve, and you can play with. Even if you are unexperienced user, you can play with it, but you won't be able to cause too much damage if you set the setting wrong, because this kind of thing can get a little bit dangerous if you are exceeding your operational parameters, right? Okay, next one from Brian. With the current algorithm, how scalable is the proposal? I think Brian is talking about the number of users within the system. What if an even larger IoT network with significant more users try to use Paretos would it still be able to decide on the policy effectively? Yeah, I agree. This thing is not scalable. All right. So any of this kind of system, if you have a limited number of resources, but many users try to access it, eventually it's gonna break down. So you eventually you're gonna have a queue. So everybody will get their service in a sequential way instead of doing this concurrently. Concurrent computation or high throughput computation has always been a difficult challenge, a major challenge for computer scientists. So this kind of deadlock or other issues that might come up with concurrency is basically unresolvable with current computation model. So until we hit the time when we have something like quantum computer, this thing is always going to be there because you have a system that operates in a sequential way or partially parallel way, but you have a more demand than the resources, then it's going to create problems. Okay, so what I feel here is as long as we have redundant resources within the room or something that will basically diverse part of the traffic or part of the user's activity to a different resources, we should leverage that to create parallelism in a temporal or spatial kind of way. So maybe we figure out a way so one of the user will not use this room while the other person is already in the room. So maybe some kind of user-friendly way. So in that case, we avoid this kind of a conflict in a preemptive way instead of waiting for this kind of war to happen. Okay. Does that answer your question, Brian?
Yes.
Okay, next one from Noah. I think it's similar question. Is the usability of Paretos tested in real life smart home environment? I would say no, based on their current narrative in their case. Okay, next one from Grant. What is the feasibility of extending Paretos to commercial applications? I think I partially answered that question during the presentation. Architectural wise, you can have that API to enforce access control. So you can have a kind of a uniform API that use Paretos to talk to the user before it grants you access. That's not a problem. Still, for instance, one of the example is I think a key establishment protocol designed by MIT, I think it's called similar name, is Kerberos, right? So that key distribution system is for access control as used by a majority of IoT devices. So adopting that is not so much of an issue because all the IoT or majority of IoT devices use this kind of client server architecture. But the problem still is to actually have a good user experience once you have this thing in place. That's going to be difficult. All right, so next one with Xiangong. What happens if some parties do not cooperate when conflict happens? E.g., a high priority party do not respond when part conflict arises. Yeah, that's the thing. So you need to have someone like an arbitrator with the final say, right? So if you don't have response from the higher privileged user, maybe after a certain timeout period, you give everybody a compromise, so you are stopping the service as the mean value between the conflict, the two conflict ranges. So something like that. You need to have a final saying. Some decision need to be made at the end of the day. So you cannot argue forever, right? Okay, so next one from Alvin. How well do you think Paretos can handle when it or a device enter a unknown state? Alvin, can you elaborate about your question regarding unknown state?
It feels like there's like set states and like set situations that they considered when for Kratos, like
hard competition, soft competition, things like that. So like, I don't know if it's possible, like maybe in the more complex setup, or maybe if like some corruption happens, how well do you think, I guess, Kratos would handle being in those unknown states?
I think it's like as long as the priority, because it mainly depends on priorities for those conflicts. Yeah, it mainly depends on priorities and what values you're setting it to. So I'm not even sure if it's able to get into an unknown state, because if a priority were to get corrupted, it's gonna end up with like one priority is still gonna be greater than the other priority. So it's still gonna end up with like a decisive factor where the higher priority will be able to decide what happens then. I see.
So you by unknown states, you are saying that is caused by the conflict?
I think by unknown state, I mean like, yeah, maybe like if a conflict arises and like that conflict isn't like, I guess like it doesn't know what to do with the conflict because it's not like defined, I guess, or like they don't, yeah, they don't have something defined for that conflict.
I think it's because you just check like, because if the conflict occurs, if you try to have access to the same device and you try and set the values of that device to a specific range, that's when the conflict would arise. I don't think everything has to be specifically defined before even Kratos is implemented too, I think. Like
So
the
Okay.
would every
So
single possibility be considered?
maybe, we can do a pre-policy enforcement check. So whenever, let's say, two users input their policy, before we even do a compare, we can have a logic process and try to avoid unknown state in the first place. So it's similar to when you try to set a user with a privilege that you cannot set. If there is a possibility of an unknown state caused by the reconciliation between policies, we'll just ask everybody to you know, revise their policy. So that's just a prevention mechanism. But still, this kind of thing, yeah, it can always get a little bit annoying. Does that make sense?
Yeah.
Okay. Next one from Jafet. Is this type of control system feasible with an IoT network that is composed of different smart devices of different vendors? Since it seems that they only use the Samsung SmartThing platform. Okay, this is somehow related to Grant's question. So, Dawei, do you want to take this question?
Oh, yes. So I think they can just modify the apps and reinstall it on whatever platform they're using. It still works.
Yeah, so I agree. So if you take a look at the communication protocol for all those smart devices, they are basically the same. So if you do a small experiment, you take a look at the APK of multiple smart home devices, Google Home, Samsung SmartThing, things like that. If you check out their source code, they look pretty much the same. They are not being very inventive. Okay, so vendor wise, they might have different technology to achieve some kind of applications based on their own technology. But from the communication perspective, they all look pretty much standard. So enforcing this kind of access control, I would say it's not very difficult, although it requires the negotiation, so all the vendors agree on this protocol to make it a standard. But enforcing it shouldn't be too much of a problem, because communication as of today is, well, rather than it's a highly standardized area, including the device that you use for communication, including the protocol you use for communication. all the things has been specified by industrial group or academic researchers or some other kind of alliance. So they all agree on this kind of protocols and implementation. So they have similar kind of characteristics. So attach access control system into a standard agreed by a group is relatively painless if they all agree to do that. Does that make sense, Tibet? Okay.
Yes, it does.
All right, next one from Matthew, last one. Would the localization of the decision-making process help to lower latency instead of sending information to backend modules? So Matthew is talking about having a local decision-making logic. So maybe the app can decide by itself, right?
That would definitely reduce the latency, but I think every app needs to have a set of policies. Like, since the backend's the one that contains all of the user policies and user credentials, you have to distribute all of that to each and every user. So there's gonna be a problem with like synchronization and
Yeah, that question, the answer to that question might get us into some kind of deep water. So instead of a centralized control system, now you have this kind of edge devices that can make its own decision, but it should not step over its bounds, right? So I think there are multiple research groups in the CPS domain, cyber physical system, working on similar kind of problem. Some of them propose to use like a machine learning system, such as this kind of thing called a teacher-student model, where you have a very complex machine learning model at the central server to make decision, and you can simplify it using the local data, trained by local data into a compressed, smaller machine learning model, which you can put it into the edge devices. So that's one of the solutions. Well, one of the proposed solutions that might help. But yes, I think this is the direction that we're going. But it's just the direction that we're going right now in the recent few iterations of CPS research. You know, this kind of thing goes back and forth. So back in the very old days, when we talk about the computer system design, we were actually having isolated subsystem working on its own. Then people start to, envision that if we can have abstraction, so everybody, all the subsystem will provide a uniform interface to the upper layer, so the upper layer doesn't care about the mechanism, how the subsystem is working. That is kind of a centralized way. And then recently we moved to this distributed way again. So instead of having a heterogeneous system with a homogeneous system, we want to have this kind of heterogeneous system where each component doing its own thing and provide their own perspective of the sensing task. So this thing goes back and forth. So localization, it certainly has its advantage, but that doesn't mean that centralization method doesn't have any advantage. So while we put something into edge devices, it will solve some of the problem, including the communication latency, but it will maybe complicate other issues. So it really depends on your task or what you want to achieve here. If the latency right now is a big problem, then maybe localization is the way to go. But if your network communication is reasonably good, maybe a centralized decision won't be so bad of it. Okay, does that answer your question, Matthew?
he
All right.
may have left. Yeah.
Okay, so I think we finished all our questions today, but remember that you still need to make a response in the discuss. I will give everybody instruction where to upload your video and how to modify the markdown file and preview it before you submit it to the GitHub repository by Friday. And starting from next week, I will present a few other papers related to wireless security, and you can start working on your final reports, which is due at the last day of the instruction. Okay.
Okay.
All right. Thank you, everybody, for coming to the last student presentation this week. And next week, we will have two presentations. I think it's related to wireless sensing and radio-based authentication.